Hello, welcome. This is for my Calculus 1 class. You have a take-home quiz and it has a problem just like this. Actually, it's number 10. Actually, this is not your number 10. This is, I should have wrote, this is like your number 10 because I changed the numbers a little bit. But it's this cool problem, man. I love this problem. You have to find the speed that will minimize the cost of this 350-mile delivery trip. So the thing is, you know, if you drive too fast, you have a fuel cost, and you also have to pay your driver wages. So you have a fuel cost, and you have to pay your driver wages per hour. That fuel cost is per hour, and the wages are per hour. So the idea is maybe he should drive really fast. If he drives really fast, I think he'll burn up a lot of fuel, and the cost will be high, but he'll hurry up and get finished, so his wages won't be too high. But if he drives real slow, he'll save fuel, but he'll take him all day and we'll have to pay him a lot of money for his wages. So there's some balance. What speed should he drive to minimize the cost? So we need to build a cost equation. Now the key idea to this problem is, you know this, distance equals rate times time. And then if distance equals rate times time, then time equals distance over rate. Now what is the distance of this delivery trip? 350 miles, so the time is going to be 350 miles is the distance over his rate, and his rate is the unknown speed, v. So this is the time for the trip. I need the time for the trip because in order to develop a cost equation, I have the cost per fuel, but it's per hour, the cost of the fuel per hour. So I have to multiply the cost of the fuel per hour by the number of hours of the trip. The number of hours of the trip. The time it takes for the trip. And I'm paying him or her $9.50 per hour. $9.50 per hour, I better multiply that by how many hours it takes for this trip, which is 350 over V. So now, that was the key. We have developed a cost equation, and you know how to minimize cost. You take the derivative, set it equal to 0, find the critical number. That critical number is probably the minimum. I can help you. Let's do it. Well, before I do a derivative, let's do a little simplifying. I might need a calculator. Let's see, one of these v's will cancel, and I can simplify the 350 over 400. Well, I think I can call that 7/8. 7/8 v. Plus, I'd like to know what 950 times 350 is with a calculator. The answer is 3325. 3325 over V. That's 950 times the 350. Okay, this is my cost equation. I want the derivative. The derivative of this is 7/8 with respect to V. The derivative of here, we know how we need to move this up. Call it v to the -1. Do negative 3325, v to the -2. That's a power rule. You move it up. Do a power rule. V to the -2, which I put back there. This is my derivative. I want to set it equal to 0 and solve for v. I'm running out of room here. Maybe I got enough room over here. Let's see, I will add this term over here to this side. So I'll have, moving right over here, 3325 over v squared equals the 7/8. Now what? Multiply by v squared. 3325 equals 7/8 times v squared. I guess I want to multiply by 8/7. And so when I multiply by 8/7, I get v squared equals, multiply by 8/7, let me check my calculator. 3325, what is that, 3,800? 3,800, I could have done that in my head. Take the square root and we get the answer v. The answer v is the square root of 3,800. I'd like to know what that is. It's roughly 60-something miles an hour.
61.64.
61.64 miles per hour. That's the speed he should drive to minimize cost. Total cost. Thank you very much. I hope you enjoyed that problem.